Welcome to this virtual reInvent session on getting into production fast with AWS IoT Connected Factory Solution. My name is Prashant Adiraju. I'm a senior manager in the IoT Partner Acceleration team in AWS. And I'm joined today by Thomas Cummins, who is a senior partner solution architect in the IoT Partner Acceleration team in AWS as well. And I'm quite excited that Stuart McCutcheon, who is the Global Vice President of Sales and Customer Success in the Siemens Digital Industry Software, is joining us as well to talk about some of the things Siemens is doing with AWS in this space. Now, before I sort of dive into this session, I want to just establish some baseline context, right? If you look at industrial IoT, Industry 4.0, it essentially is a data lever, right? It sort of brings data from machines, data from field assets at the edge, does edge computing, cloud computing, analytics with newer technologies like ML and AI. And ultimately, it's about a combination of all these things to really improve the performance and productivity of manufacturing sites that are industry heavy. They've got asset heavy models, they've got asset heavy industries. Now, it's not only about the performance productivity of these sites, but it's also about transforming the business models, things like machine as a service. So what we want to do in this session is sort of give you an overview of all of the trends that we're seeing in the space. We're seeing an average impact customers are seeing with regards to the connected factory proposition. We'll sort of dive into a solution architecture. We'll actually have a demo to share with you as well in the session. And then lastly, we'll talk about how Siemens is building on this foundational set of capabilities to drive outcomes for customers. That's what we hope to accomplish in the next 30 minutes or so. Now, what I want to start with is some of the trends that most of you are already familiar with, right? Look at data as an enabler, digitally executed manufacturing, where improving operational equipment effectiveness is a goal. Look at production runs of one individualized product. Look at product as a service. That's actually changing the business model to sell products or machine as a service. And then this whole aspect of connected products so that you better understand how customer behavior, how customers are using these products to sort of build next generation products, if you will, right? And then there's a strong desire to sort of make manufacturing far more sustainable because they're sort of the largest consumers of energy. But what I want to focus on in this session is really about this first trend where manufacturers are recognizing that they have a wealth of data that's locked up and that data can be leveraged to really improve operations and productivity of manufacturing sites. And I sort of want to talk about this data theme. And that sort of brings me to this data flywheel, right? And you look at this data flywheel, you could start at any one of these locations, but data is sort of the driver. So you could be looking at production data and you're looking at how to make production more efficient. How do you make quality of the product higher? And many other KPIs like that just to help with production. But once you ship the product, there's this desire to keep the product connected or smart so that you can really understand how these products are being used, such as a connected car or a connected vacuum cleaner. And with the ability that it's connected, you now have the ability to do constant updates, constant software updates to that product. And you're able to use that information from how customers are using this product in the design of the product itself. And that's sort of the R&D data flywheel in itself. Now, once this is designed, now you need to be able to leverage this information from how customers are using these products in the design and then push that data back into production so that you're able to iterate at a much faster clip. And it's this data flywheel that's ultimately going to provide customers with a better product with better quality. You're able to improve the productivity of the plant. You're able to improve the experience in terms of how customers consume the product, etc. Right? Now, in terms of what we see is that customers that consistently leverage the value of their data, they're able to reduce their product development costs by up to 50%. They're able to improve their operating costs by 25%. They're able to improve their gross margins by 1/3. And that's pretty compelling statistic. And it is, if you look at the picture on the right, you see, one of our key partners, Hitachi, they've done an extensive study across different use cases, everywhere from improving supply chain, improving product quality, improving worker safety, to reducing energy costs. I think the business case to sort of go do this in terms of leveraging data is quite compelling. Now, here's an example of Volkswagen that's actually merging the physical shop floor with the AWS cloud to really improve production efficiency and productivity by up 30%. And what they're essentially doing is they're partnering with AWS to improve the productivity of their plants, and as a result, they're able to save billions of euros when data from all of their 124 Volkswagen group of plants can be evaluated in a very standardized manner. And this industrial cloud is essentially a data laver. It's about improving the productivity of the plants by 30%. Now, there are challenges to do this. And the challenge is, how do you liberate this locked industrial data, right? And some of the biggest manufacturing challenges that we see is manufacturers are challenged to have visibility into their operational technology data, from machines such as PLCs, programmable logic controllers, like the SCADA systems, performing root cause analysis, like for example, when a line or a machine goes down, improving throughput without sort of compromising product quality, and understanding, for example, details around micro stoppages of machinery in real time. Now, even if you take even some of the advanced implementations that many of these customers use, like factory information systems, these today cannot provide visibility at a component level. Example, take motor in a machine. And the vast majority of these manufacturing customers cannot do any analysis in real time at this sort of granular level of a line or a machine, or even at the component level. And it is this problem that we're looking to solve with the Connected Factory Solution. And the vision here is we want to help a vast majority of industrial customers to make it easy for them to free up their operational data at scale. And we want to be able to provide them near real-time visibility. And what this near real-time visibility does, it could start with simple dashboards to looking at things like deeper analytics with ML and AI, is to help understand the reasons around production stoppages, production micro stoppages, improve throughput without compromising product quality. You want to understand trends that lead to, why is a particular product or a production line suboptimal in terms of quality that's being manufactured. And additionally, all these customers are looking for data visibility at not only the enterprise level, they want this granularity at the plant level, line level, down into the machine, down into how their process and their production levels are being done. Now, all of this is not possible today because the data is sort of locked up. And that's essentially the intent here with the Connected Factory Solution, to unblock that data. And what we're sort of bringing together to address unblocking of this industrial operational technology data is 4 things, right? One is there's a standardized architecture. We'll sort of dive into that in the next section. The second piece of that, there is a certain set of industrial machine connectivity capability that we're bringing in to sort of address this problem of bringing data into AWS in a very standardized manner. The third thing is we're training a set of global system integrators and regional system integrators to help with the last mile deployment and activation. And the fourth part of this is there's going to be a diverse range of solutions that manufacturing customers want. They want to be able to reduce their energy consumption. They want to improve the performance of their manufacturing lines. They want to reduce energy costs. And there's many more of these. So these are all the ISV solutions that we're sort of pre-packaging and sort of bringing to market together. Now, in the end, what the benefits are is that it helps customers get production solutions and proof of value deployments running faster, as quickly as possible with this pre-packaging effort that we're doing. First, customers don't have to invest significantly into collection of data. That's really considered undifferentiated heavy lifting. Second thing is, customers are able to organize and store their industrial data in AWS inside like an operational data store. For example, they could use this for hot data that is accessed frequently, or could be warm and cold data that's accessed infrequently, and they could actually define virtual assets and asset hierarchies. So that sort of provides structure and context to their data itself. And third, with all this data being streamlined, customers are able to recognize immediate business value, right? Through visualization, for example, they're able to get all their sources of truth. And fourth, they sort of get a kit to be able to do this repeatedly across all factories and lines. And lastly, what it does is, with data sort of organized, you're sort of on that Industry 4.0 journey, which I talked about earlier. It's all about this data lever, and you sort of help you achieve a wide range of business outcomes. Now, here's an example of how we see customers go down this sort of three-phase approach, right? They start with a pilot site, they get pilot site into production, they realize the business value out of that pilot deployment. They do a maturity analysis because they might have 100 to 300 sites across the globe, and each site is going to be different. And that maturity analysis defines them. How do they repeat that one use case? It could be reduction in energy costs. How do they do this repeatedly across all of their sites? And that's sort of the scale-out approach, right? Which is delivering a scale-out proposal across all plants. And this is sort of the typical journey that we see in terms of how manufacturing customers are really modernizing their operations with a solution like Connected Factory. Now, here's another example. Genie is actually a Terex brand. They're a global manufacturer of lifting and material products, and they deliver certain solutions, and they're really looking to maximize the return on investment, right? So Genie needs to really improve the quality and reliability of its Genie brand. For example, lifting equipment, and they want to eliminate the problem of paint chipping, missing parts, and they ultimately want to improve the paint quality of these parts. And because there's ultimately an impact on those parts impacts warranty, and that impacts costs, right? So Genie deployed a solution to really do a repeatable paint process monitoring solution spanning from their entire factory floor to the cloud. They're able to bring data into SiteWise. We'll look at a little more about the architecture. They're able to ingest that data. They're able to analyze the data. And by basically processing all this information, they're essentially able to reduce warranty claims, right? By ultimately improving paint quality and durability of all its lift products. Now, I want to make one last point here around the Connected Factory partner community that's playing a critical role in this journey for customers, and want to highlight why partners are important. Because we see more and more enterprise customers are modernizing their manufacturing operations with AWS. While every company is different, and some feel very comfortable to tackle these challenges on their own, the most companies we work with are looking for help. Companies lack the deep knowledge and the technology breadth to be able to design the right architecture, being able to deploy this globally, be able to monitor their Industry 4.0 or industrial IoT technology stack on a global basis around the clock. Second piece of it is customers need qualified hardware. They need a wide range of solutions. They need edge software. They need consulting and deployment expertise. So it's to address this diverse need, we're sort of bringing in this partner community of different partner types. Starting on the bottom, you look at that there's a set of qualified hardware. You have edge partner technologies. And this top two layers is all about standardizing how we connect to machines, how we bring data in, and use the data and unlock the data to drive the Industry 4.0 journey across the use cases I talked about. The third layer here from the bottom is all about that last mile deployment. How do we sort of make it easy for customers to start their pilot projects, and how do they go down this path of the three-phase journey that I talked about? And then the fourth point here, which is the top layer, is all about that solutions. So with this in context, what I would like to do is to invite Thomas on to talk about the architecture itself, provide a deeper view of the solution architecture, and also provide a demo around this. Thomas?
Thank you, Prashanth. We'll now take a look at the reference architectures for the Connected Factory solution. The Connected Factory solution architecture is based on the AWS IoT Sitewise service. We use this service to ingest data from the manufacturing plant floor. And on the left-hand side, we see a box labeled on-premises. So these would be the data center or the actual industrial site of the customer. We want to extract data from historians, SCADA systems, PLCs, and other IoT connected devices. And what we're going to do is rely on partner connectivity applications to be able to do that industrial protocol translation, to be able to translate from the disparate number of industrial protocols into something we can actually ingest into Sitewise. And the way that works is we run the Sitewise connector, which is inside of AWS IoT Greengrass, to ingest data over OPCOA and then stream it into AWS IoT Sitewise in the AWS cloud. What's happening here is we actually have a data model that's provisioned inside of Sitewise, as well as a managed time series data store where we're storing all the data. And then there's also a feature called AWS IoT Sitewise Monitor that allows users to build dashboards to visualize the near real-time data. This can be useful for personnel such as operators or production supervisors to see data as it's flowing into the cloud. On the rest of this architecture, what we're seeing is a number of different services that enable builders, such as teams from regional or global solution integrators, to go ahead and build solutions, and customers themselves to be able to build if they have teams ready to do so. Some of the capabilities include that move on from AWS IoT Sitewise is building alarm management tools. So we can actually stream data out of AWS IoT Sitewise into AWS IoT Core onto the message broker. And from there, we can use the rules engine to route data into AWS IoT events to build event detection models. And let's say respond to alarm events or events that need immediate attention and trigger notifications via Amazon SNS. And again, the consumers of those notifications could be operators or production supervisors. We also have the capability to move data into a data lake. And so we see two paths to do that. We see streaming data via Sitewise going into AWS IoT Core, then via Kinesis Data Firehose into an S3 bucket. Or there's actually a blueprint that's supported by the AWS IoT Sitewise service team that uses a Lambda function to mirror the data from the time series database in Sitewise and put it into S3. And from there, you can use a number of different services, including Glue, Amazon EMR, AWS Fargate, to go ahead and process that raw data and turn it into process data in that silver and gold bucket there. You can then move data into a data warehouse to take advantage of services like Amazon Redshift, and then use services like Glue to build data catalogs that categorize the data and then be able to query that data using services like Amazon Athena. And then you can also use data that's stored in Amazon S3 to use to train machine learning models with Amazon SageMaker. And then finally, we have a BI reporting tool called Amazon QuickSight, which can be used in conjunction with Amazon S3 and Amazon Athena to go ahead and query data and build intelligent dashboards that can be consumed by users such as data engineers or BI engineers or operators and production supervisors as well. So that's the overview of the real-time data ingestion paths for the connected factory architecture. But sometimes we need to bring in data from legacy applications or on-premises storage that don't have any connectivity directly with Sitewise, and we need to use other services to bring that data in. So other AWS services, including AWS Snowball and AWS Database Migration Service, can be used to pull that data in, or we can build custom applications to pull data in from legacy applications using Amazon API Gateway. Now, one particular piece of that connected factory architecture is the edge-to-cloud connectivity piece. And so this is often one of the most challenging and time-consuming parts of the architecture to solve for. And the reason for this is there's a number of implementation challenges for manufacturing customers. In a variety of different manufacturing plant floors, there's lots of different PLC brands, there's lots of different industrial protocols that have to be dealt with, lots of different network topologies that have to be solved for. And so we wanted to produce a technical artifact, a quick start to get our partners and customers up and running faster to be able to move data from the plant floor into the cloud. So what we did is develop the Industrial Machine Connectivity Framework, or IMC framework. And what this does is bring together a subset of those services that we saw in the Connected Factory overall architecture, and really focuses on what we label here as edge software coming from third parties. And this is allowing us to actually connect to the PLCs and other SCADA and historian assets that are on premises and bring that data into AWS IoT Sitewise. And here's the actual architecture of this IMC kit that we've built. What it does is rely on partner connectivity applications, and two of them shown here is Ignition Server, built by Inductive Automation, and Kepware, which is built by PTC. And in addition, Stuart will be talking in a moment about Siemens capabilities with their Industrial Edge software application and their other software services. So today we'll be focusing on Ignition, actually, and we'll get into a demo in just a moment. What these partner connectivity applications are doing are actually interfacing with the PLCs and historians and even other SCADA systems that are on premises. And then we have a asset model converter, which is shown on the bottom right-hand corner, which is a serverless application flow that essentially maps the asset hierarchy and tag structure from the partner connectivity applications. And in a moment, we'll get into this demonstration with Ignition. And it actually maps that tag structure into Sitewise. And what it's doing is provisioning the asset models and assets and asset hierarchy in Sitewise, and then allows the data to flow via the Sitewise connector that's running inside of AWS IoT Greengrass. So let's take a closer look at the asset model converter architecture. What's important here is that we have a number of partner edge software applications, and those are labeled on the left-hand side. So right now we support Ignition Server and PTC, and again, Stuart will talk in a moment about Siemens capabilities. And what we've built is basically an architecture that will take the asset hierarchy definition object inside of each one of these partner applications, and it will convert it into a format that is normalized for Sitewise. So what this means is data comes in from the partner connectivity application, and then we convert it into a normalized structure using a Lambda function that's labeled AMC for Asset Model Converter. And the first part of this Lambda function, AMC1, is doing that schema conversion. And the second part, labeled AMC2, is actually taking that normalized structure, which is stored in two DynamoDB tables, and provisions resources inside of Sitewise, namely asset models and assets. And now let's get into an actual demonstration where we're going to take a look at using Ignition Server to simulate some tags and bring that data into Sitewise and show you how that works. So we'll get right into that. We'll now take a look at the IMC architecture demo. What we're going to do is simulate some edge devices which would normally be running on premises on the plant floor with EC2 instances that we're going to run in the AWS cloud. We'll spin up two EC2 instances. One of them will run Ignition Server, which is the partner connectivity application that we're using for this demo, but this could be other partner connectivity applications. Kepware is also supported. And so these are the connectivity applications that are actually pulling data from PLCs. And so in this demo, Ignition itself is actually going to simulate the tags and the values for those tags. And then we're going to pull that data in via OPCOA through the Sitewise connector that runs inside of AWS IoT Greengrass and bring the data into IoT Sitewise. And the first step of this is the AMC, or the Asset Model Converter, to running. And it will convert the tag hierarchy that's in Ignition and provision it in Sitewise. And once the assets are provisioned in Sitewise, the data can flow. And so let's take a look at that running. Here is Ignition Designer. It's the UI that you use to configure the tags within Ignition. And here on the left, we see line 1, line 2, line 3. So 3 simulated lines of a manufacturing plant with several machines in each one. So in line 1 case, it's we have a conveyor, a haul-off machine, and a stamping machine. And inside of the conveyor, we have 4 different tags which have simulated values being generated for them. So motor amps, motor RPM, temperature, and vibration. And so this is the hierarchy that was defined inside of Ignition. And in a real world scenario, these would be the tags coming from physical PLCs connected to real industrial assets. And if we go over to the Sitewise Service Console in AWS, what we see is that same exact industrial asset tag hierarchy being provisioned. And this is what the Asset Model Converter is doing. It's automatically taking the tag structure from the partner connectivity application and provisioning it inside of Sitewise. And here on the bottom, we see those 4 same tags, and we see the latest values being updated for those tags. And so this is Sitewise running We're ingesting the data for the time series values, and that's stored in the managed time series data store. And we have the assets being modeled in the managed asset model data store. And so once we have the data flowing in, we can build applications on top of it. And one easy way to get this going is to use Sitewise Monitor. This allows us to build managed dashboards to visualize the real-time data. And here in this case, we're visualizing the 4 tags that we were just looking at for the line 1 conveyor that we were looking at. And so here we're seeing a couple different ways you can actually show the data. Here we have a line chart. Here we have a KPI with percent change from the previous value. And here we have a dot plot. And so this has been a quick demo of how a partner connectivity application, in this case Ignition, integrates with Sitewise to automatically provision the tags inside of Sitewise and then stream the data into the Sitewise service in the AWS cloud.
Thank you, Thomas. It is a pleasure to be able to speak to you all today. I'm Stuart McCutcheon with Siemens Digital Industry Software. I'm part of our global sales and customer success organization, focusing on new product development and introduction, and our global strategy on digital twin. Siemens, as many of you know, is a global leader in both industrial automation and digital industry software. I wanted to take a few minutes to share with you our connectivity approach from edge to the cloud and how we partner with AWS to accelerate this for our joint customers. Siemens provides a continuum of solutions that connect from edge computing at the factory floor. In point of fact, 1 in every 3 controllers, often called PLCs, is a Siemens PLC. However, our solutions also support more than 20 protocols and communications standards. And with our partners with AWS, since 2014, by the way, and their cloud and IoT services, we are connecting and delivering solutions from the edge to the cloud with pre-tested solutions that are often faster to deploy, operate, and easier to build on top of. For example, leveraging our Mindex low code, thus delivering value faster to our customers. With the limited time, I thought I would share one example reference architecture of a combined solution. In this example, our MindSphere IoT as a service solution, outlined in purple, is delivering proven industrial application or apps from the cloud and the data connected through our new industrial edge solution. Leveraging the industrial connectivity solution Thomas demonstrated from the edge on the shop floor through our MindSphere connectivity to AWS IoT Core, Sitewise, Data Lake, and AWS Cloud Services, DynamoDB, for example. Today, we deliver MindSphere apps and solutions on AWS, leveraging more than 61 AWS services. I also want to share a real customer example that is in production today with Siemens and AWS at Air Products. Air Products is a global, diverse company and is a leader in providing air handling and processing solutions to manufacturing industries, also for healthcare and medical products. By connecting equipment in the field to Air Products Process MD using MindSphere running on AWS, Air Products has been able to deliver its expertise to customers to help them reduce downtime and energy costs. New capabilities created by cloud computing and analytics are opening up additional avenues for companies for the company's extensive operations. Before extending Process MD via MindSphere, Air Products did not have a solution to bring in customers' data associated with Air Products equipment in their plants. They knew they needed to have a secure global connection that would be end-to-end, encompassing design, implementation, all the way through to service, supplying continuous data back to Air Products with no interruptions. The value proposition behind this idea for Air Products customers is to save our customers millions of dollars in avoided downtime and repair cost, as well as energy savings, Hubert said. He added that Air Products customers using this service can expect to save between $50,000 to $600,000 annually. Thanks to our partner AWS, this is just one of many customer solutions. I look forward to sharing others in more depth with you in the future in virtual sessions. Thanks for your time. Now back to Prashanth.
Thank you, Stuart. So what I'd like to do is sort of wrap up this session. I want to just leave you with a few pointers and a few ways in which, if you're a customer, how do you get started? If you're a partner, how do you get started? Right? So I'll sort of leave you with those pointers. So as we talked about, the purpose of this session was all about unlocking industrial data so that customers can really modernize their manufacturing operations and really get a wide range of benefits. Now, if you're a customer looking to accelerate your industrial IoT efforts, as we've talked about, we've got a growing partner community that can help you, and we've got a specific sets of technical assets that can help you get started. You might be have built a business case, you're looking to mobilize for production and want to start to go down this journey. Like I talked about, there's like a three-phase journey. We've got certain assets mobilized for production, which is offered by our growing partner community as well as by our professional services team. Our partners also can help you really understand the business case. If you're looking, saying, hey, I want to go optimize energy costs across all of my manufacturing sites, how do I stand up a quick pilot? In a few weeks' time, how do I look at the solution, explore what is possible? And that's where we're sort of bringing this together. And then I'd like to leave you with a few sets of additional documentation that you could look at, and feel free to reach out to AWS and its growing partners to help you on this journey. Now, we continue to look for partners to help build a solution, partners that have very differentiated domain-specific solutions. So quite eager to work with you on this. We've got this growing list of partners. You could be an OEM offering qualified hardware, got deployment partnership expertise as a global system integrator or a regional system integrator. You're a technology partner like an ISV that's got very specific domain-specific solutions. So all of these are partnership opportunities for the Connected Factory solution. So with that, thank you for taking the time today in attending this session. And I'd like to remind you to please also fill out a survey. We look forward to your feedback. Thank you very much.